phi, and they're both complex field. That's it. Complex. We are giving the action S of psi. Equal 0 plus mod, phi theta mod plus S. M of and delta S where dm equals integrate from 0 to beta tau.
The dm?
Dm, dark matter. dt of r. Just copying the integral is given each. And the interaction action G beta tau d r rho psi plus psi conjugate. Okay. So they're asking us to take these two integrals and do a Fourier transform, mostly to remove the derivative and yes.
It's integral from
0 to
0.
The same. Basically, we want to Fourier transform, mostly to remove the derivatives, so we can get something that we can diagonalize in simple matrix, possibly, or solve the function integral. Okay. So in order to do the Fourier transform, first of all, I'm going to define my convention. Define the Fourier transform convention. Q.
זה G שלפני האינטגרל של
I K vector R minus omega n tau. Okay. Notice that I wrote a sum here, but because our integral on space is from minus infinity to infinity, the k itself would be in a integration. So when I write a sum in the Fourier space, it just has a convention that it's, at least for me, it's much simpler to keep track of. But the k has an integral. All right. So we'll do. Let's go back to so let's go back to so double integral psi to the value squared. We're just going to put it in. R. Sum over Q tag. I have two functions here that multiply with each other, so it's a multiplication of two sums. So we have sum over two indexes. Q. Conjugate E. Now the first one I will give it some space minus again some space down. Now the conjugate term here, will give us a minus in the sum right up here. It will be minus k tag vector minus omega n tag. All right. Now, putting the integral back into the sum itself, the k in the integral from minus infinity to infinity will be a delta for simple Fourier conditions. And now I would just want to quickly look at the omega n term right here, right? I'm just going to take this integral by itself for a second. E to the minus I n tag tau. This is a known integral with a solution of solution goes like 1 minus e minus I omega n minus omega tag beta divided by, let's just say a. The constant here doesn't really matter. So we know from Mitsubar that the Mitsubar frequencies of ours would be omega n equal to pi n divided by beta. So the term, just gonna write it here, e to the I. We're just gonna put this in where this index, or call it m, would be 2 pi beta. When beta cancels out, n minus m, and we see that no matter what are the two indexes, this will be equal to 1. So overall, all of this is equal to 0, except if this exponent is 0, then this integral will just be an integral over 1 to give us beta. So even though this integration is not from minus infinity to infinity, and we don't have the normal condition for a delta function, this, in our specific case, this will also give us an answer function, also the integration over time. So overall, this will give us, right above, q time equals over q to the value beta. Yeah, there should be like a beta here, but I didn't take. This is the convention that I talked to before. I'm not taking there should be 1 over square root of beta here, but I'm just ignoring the normalization factors. If you'll allow me.
Sure.
I don't want to break it as well. So okay.
Can you change the marker?
Yeah, I think I have a few here.
The red one is
Two
good.
selection.
The red one is good.
The red one is special marking. The big one?
No, שחור. Oh, in the big circle.
Too much of a flavor, please. Alright. Well, let's do the second term. Creation tau, beta, creation tau. Now, this derivative over the Fourier sum will basically reduce the k vector dark. So we have a I k vector for the non-conjugated part, and then minus I k tag from the conjugated part, and we have q. It's also bad. Then q conjugated, right? And then e the I k is k tag, r vector minus omega n minus tag tau. This right here, exactly as before, will give us Same condition. God damn.
עושה טוב.
Fine. You broke it.
The big one.
I tried the big one. It's bad.
Oh.
This will give us the same condition as up there. So rho equal to. There's a sum of the q here. I'm sorry. Sum of the q. K vector absolute value squared. I times minus I is 1, so it's nothing. So it's squared. Similarly, of theta give us, now this term right here will give us an I minus I omega n. So overall, doing the same exact transformation, sum over q minus I omega n q to the value squared. So combining everything together, this and equal sum of the q of m squared plus j, so the value k vector squared minus I omega n of the value q squared. I got something diagonal. Very good.
Couldn't we just say it?
You can, but I wanted to at least one do the Fourier fully, and we'll do it again.
רגע, איפה האינטגרל המרחביה במקרה הקודם? מה היה איתו?
The spatial integral create the k, the delta in k, and the time integral will create the delta in omega, using omega in right? Now we have this term of ds. So before I write the ds, I have to define the transformation of rho. Similarly, rho equals sum over q, or q, e to the I, a k vector r vector minus omega n tau. Exactly the same. One thing that we need to notice before I move on.
איך אתה יודע שהאקספוננט עם אותו מקדם K ואותו אומגה?
This is sum over everything. This is just the k and omega n are just notations. But the specific omegas, for example, will be defined by your space, by your sum from 0 to beta. So the omega n will be the same. The k is continuous, so it's not really much to say about it. Okay. Before I move on, just want to say that rho, as defined in the question, is equal to psi dagger psi, or psi to the value squared. I'm not gonna use the big psi here, but what it gives us that rho is real, right? When rho is real, we have a very special condition that we need to remember. Rho of q equals rho of minus q conjugate. This is a condition, this comes from rho being real. It'll be useful in a second. I have space though, I can do it. So, S equal to integration 0 beta tau integration dr sum q tag of rho q e to the I k r times omega n tau of these times, it's like q tag e to the I k tag r is omega tag n tau and plus now the conjugate term q tag conjugate e to the I minus I k tag r minus omega n tag tau. Notice, since I'm summing up over phi dagger, I can take the same index on the both of those Fourier transforms. Since it's a sum plus a sum, I can choose to sum up each index together. For example, psi 1, I can sum it up with psi a conjugate 1. Okay? אני מחליף את הלוח, אז יכול לראות. Now, we can see that this exponent with this one will give me delta q tau, and this exponent with this one,
כן, זה כאילו Q מינוס Q.
delta q. I'm writing delta in the comma convention, not equal 0. Right. Okay, so we get it's equal to sum of q, rho q psi minus q plus rho q psi conjugate q. Now I'm going to flip the counting order in the first term. That means I'm going to take the minus from here and move it to this one. Minus, right? And then I'm going to use the rule that I wrote here, right? So it'll be equal to sum over q, rho q conjugate, so q plus rho q, psi q conjugate. And why did I order this way? Well, we need to move to the next question in the order. Section B. Can I erase everything in the beginning?
יש לעשות זה פעמיים של... פשוט פעמיים רוב כאילו.
No, I want this form specifically, and I'll show why in just a second. Okay, so in the next question, they tell us take the SD term. Wait, I think I erased it. The SD term and the interaction term, that means all the Fourier transforms that we took, and do an integral over phi in order to remove the phi's here. So I'll just write it again. I'll write everything again. Z equals conjugate D. Of E minus 0 E over Q minus of this term squared plus j value k squared minus I omega n. So value k is like q squared. This is the s, the dm, dark matter term, and now the interaction term, we have it right here. Plus OQ. Did I forget some constant? If I forget constant along the way, just tell me. There's supposed to be G here, right? Why didn't you tell me? Rho conjugate sine plus G rho Q psi Q conjugate. Now, if you'll open your homework to second section, question 1, you'll see a very, very useful equation. I'll write it for everyone.
Which one?
The last homework, part 2, question 1.
Complex משהו.
Hmm?
Complex
Yeah.
integral.
There's a question about Gaussian integral, general Gaussian integral. And V E minus the vector A matrix, V vector conjugate, V vector plus V vector conjugate U plus sorry, the vector is on the conjugate is on the U in the homework, right? This entire integral, you know it's equal to pi to the power of n divided by that determinate, okay, determinate e to the u dagger k times 1 u. Now you might ask yourself where are the matrix, where are the vectors. Very simply, a sum is equal to a vector multiplication. For example, if we take the vector, I'm going to write right here, the vector OQ, OQ1, OQ2, and then the vector, I think I wrote it the other way around, but it's fine. The vector psi Q1, conjugate psi Q2, conjugate, so on. We get sum of the Q, O, Q, psi conjugate. This will be like taking a matrix between those two vectors. So this will give us a diagonal matrix with these terms, and those two will be our vectors: omega, W, and U. Okay. Now you can see why I took rho conjugate instead of putting a minus on the Q. Just our vector line up. We have the conjugated term.
This omega is supposed to be a U. Okay.
Okay. So directly from this equation, noticing that n equals 1, the capital N equals 1, that equals conjugate times e to the minus s0. Now pi power of 1, the determinate of diagonal matrix is the multiplication of all the terms. So q n squared plus j k absolute value squared minus I omega n. And the exponent will be, this will be rho q tagger, rho q conjugate, and W will be rho q. So overall, and then there's two minuses, so the minuses cancel out. Rho q, so the value squared, times 1 over a to the minus 1, so it's just 1 over those terms. 1 over m squared plus j k absolute value squared. So I omega n.
What you said with the minuses was wrong.
But why?
It is some, it's not multiplication.
Yeah, but there's a minus on the outside from the definition of the.
There is minus before the integral, you mean? What do you mean?
There's a, well, no, there's a minus in here, so
Yeah.
this function will be the minus. It says here, and the u omega will be minus g rho q and minus,
Okay.
and the minus cancel out. But there's a g here that I forgot. Thank you. This is the second question. Just 4 lines.
What is the power of pi? Is it n or
N, but notice that in our integral you only have one integration of psi and psi. If there were vectors, we needed to do it more.
So it will be more correct to put the multiplication of the pi over this whole function. Right?
We mean in the this term.
Yes, for you have a multiplication over q. For that, yes.
Yes, right.
Yeah, but the pi doesn't get multiplied multiple times. Only the determinant. This multiplication term right here
yeah.
is from the determinant.
It's the dimension, right?
Yeah. Okay, so this was entire part B, entirety of part B. Now for part C. Oh wait, no.
So that's not a big.
They also wanted us to find SF equals sum over Q, VQ, rho Q, rho minus Q. Now remember that rho Q conjugate is equal to rho minus Q. So the rho Q, rho minus Q is this term right here, and VQ will be all of this. And there's, sorry, there's a sum here over Q, I forgot. Sum here. Okay? Right, now for part C, this was B, C.
טוב, רשום פה בסוף להראות שזה כאילו זה attractive interaction.
Interactive interaction. Did I not write it? Seem to not read it. This term,
עמוד שלילי.
no, because H is equal to pi rho minus S. So in the Hamiltonian there will be another minus here.
לא, אבל אומרים שזה משיכה, אם זה משיכה זה חייב שלילי. טכנית.
The minus comes from here. Okay, let me just let's say more explicitly. This entire term is L of Q. So this is the description of Hamiltonian using Lagrange equation. Minus L. So there's a minus here. There's a minus. then in the Hamiltonian, this gives you negative energy.
כל ה-V אמור להשפיע, לא? כי אנחנו אומרים שיש לנו משיכה, אנחנו מדברים על כל הפוטנציאל.
Yeah, but this is the V in the action, not in the Hamiltonian. The attractive interaction refers to the energy that you get. Right. In C, they tell us in regarding to omega n equals 0. So omega n equals 0 for everything. And they want us to find, they also say t equals 1. And they want us to find VR and the integral, using the integral minus infinity e to the I of x squared plus e squared equals I divided by a e to the minus rho a. The AC on? It's so hot here. Alright. So, we'll take our VQ we found here, this term. Right, VR equals, now we're doing the reverse transform for you. It will be integration dr. Okay, since I removed the omega, I go back to the integration convention of g squared divided by m squared plus j absolute value k squared. E to the minus is from the Fourier to the other direction, minus a vector r vector, where we have only one dimension, so we remove the vectors. We see that this is almost exactly like the given integral right here. We just need to divide everything by both denominator and denominator by j. So it will be equal to double integral k, d squared divided by j, n squared divided by j, plus k squared. We don't need the absolute value anymore. E to the minus I, kr. And now using the integral, this right here is pi. Using the integral pi, a squared will be n squared divided by j, so it will be pi square root j divided by m. E rho here, the exponent will be r, e to the minus absolute value r, square root of n squared divided by j. And they want us to find the decay length. Decay length comes from where this exponent is equal. The exponent is equal to the power of the exponent is minus 1. So r square root of n squared divided by j is to 1. Instead of r, it's a lambda here. This is the decay time. Lambda equal to square root of j divided by m.
מה זה היה עכשיו בקייטן? כאילו, איך זה זה?
The decay time is like it's exactly the same as decay time, just decay length here, which is asking when this exponent is equal to -1. This is the condition.
You skip the integration over space just because.
No, I use the
No, this is over k, right?
wait. There's no. Sorry, it's my bad. There's no integration over space. Accidentally added another term. This is just directly Fourier transform the other direction. Yes.
Where does this integral comes from? This integral VR equals to this integral?
This is in the question.
No, not the formula. Just you wrote this integral.
Here.
Yes.
Notice this is Vk. So Vk times e to the minus I kr. It's just the reverse Fourier transform.
Okay. Right. Okay.
Notice there's technically also should be like a normalization factor, but again, I'm not dealing with normalization. Yeah, so this was the entire question 3, and I think it's like a very typical question 3. The important stuff to remember, there's only like 3. Remember Fourier transform back and forth, 2k space from k space. Know the delta. Maybe there's more than 3. Know the delta that comes from integration over the Fourier terms of the exponent. Remember it's delta. Remember that in a real function, this condition exists. This comes up all the time. This condition, whenever you have a real function. And lastly, remember this equation. This equation solves everything. Everything in this question. Very important. Right? And beside that, everything is just straightforward. Just put everything in and calculate.
לגבי החלק שאמרת שם, שאתה רוצה לדעת איפה זה לא מתאפס.
איפה?
אמרת פה משהו בדלתא שנכנסה פה. אז לא איפה הדלתא
זה
כן, איפה פונקציה דלתא נכנסה?
No, the condition for decay length is when this exponent, the power of this exponent is -1. So you just need to equalize, say this is equal to 1.
אוקיי. אז כבר תצטרכו לדעת ממש מתי הדבר הזה יוצא -1 בשטח.
This is just a definition of decay length, decay time.
אוקיי.
All right. The next question. Next, it's exam 22, A, question 2. Previous question in the same exam. Okay, question 2, always about mean field approximation. 99% of the time it's about the Hartree-Fock. I don't actually think I saw a question about the BCS approximation, but
Yes.
there is. So I might have missed it.
ב-2020 היה, ב-2020 היה.
Oh, I guess I missed it. But if Frat will let me upload these questions, I don't mind uploading also a BCS answer. Alright. Okay, so we're given an Hamiltonian question 2. H equals to H0 plus int. We're using fermions, electrons. H0 is equal to sum over I. So I, H dagger I. And the interaction term is equals to U. Sum over I, CI dagger plus 1 dagger is I plus 1 I, where I is equal to 0 plus 1 to the power of I times V. This is what we're given. Everything. Also a bit Q. And they ask us in A. They're giving us ground state G0 equal J C of 2J plus 1. And first of all, they want us. I mean, it's not the first part of the question, but it's the simplest part. Let's do it first. They want us to give a reason. They want us, first of all, they want us to justify why this can be is the ground state of H0. It's the Fermi. Anyone have any guess?
You can apply the H interaction to the ground state and to find if the delta equals 1 or 0.
You can, but I'm trying to do it a bit simple.
Every even state gives you a positive energy, and every odd gives you negative energy because of the epsilon I equals.
Right, it's here. So if we take, thank you, to J. I'm a hot man. Alright, -1 to the power of 2 times whatever, -1 to the power of an even number would be +1, 0, 0 plus V. And if we take 2J plus 1, which means that it's an odd, V, epsilon 0 minus V. So it's very clear to see that all the odd terms will have much lower energy than the even term by a difference of 2V. So in order to get the minimum energy when our Miltonian is just H0, we have to first of all put all the population in the minus term. Only after we're done with the odd term we go to the even terms.
It might be a stupid question, but we can assume that epsilon 0 minus V is negative, right?
No, you can't assume that.
But then the ground state, the zero particle state will have lower energy. It will have 0 energy.
Yeah, but when we talk about the ground state and specifically the Fermi C, we assume that we have some amount of particles in it.
Okay.
So it will be much better to put them here. Alright. Next, they want us to take the interaction term, open it using a Hartree-Fock approximation, and show that the Fock state vanish and the direct term adds a constant correction to epsilon. Alright. So let me just write here again the interaction term. That was U sum over I. Ci dagger is 1 I. Just take 2 colors, blue and green. Wow. Right. First of all, the Hartree term are the direct term. Those are the terms where the electron interacts with itself. So I to I plus 1 to I plus 1. And the Fock term will be where there's an exchange of energy between the electrons. So I plus 1, exchange between the electron, I plus 1 to I. Fock Hartree. Okay. So let's consider what because they already told us that Fock zeroes out, so let's start with this one. So the Fock term will look like Ci dagger Ci plus 1. This will be the constant before the Fock. And of course, it's also going to be the opposite term. I'm just going to focus on one, and you'll see, and you can generalize it to the other Fock term. So Ci dagger Ci is 1. We know that only our odd level have an electron in them. So notice here that either Ci, the either I plus 1 is even, or I is even. So there are two possibilities. But if I plus 1 is even, Ci plus 1 is 0, equal to 0, because we have no electron in the even terms. And when I itself is even, I plus 1, Ca, and we operate accretion operator to the left, 0, Ci dagger also equal to 0, because we don't have electrons in our even states, or in our odd states. This term will always be 0, and therefore also the conjugate of the same term will also be 0. Okay. Now the Hartree term. Hartree term, we need to calculate Ci dagger Ci. If I is even, so this is equal to 0, very simple. If I is odd, we just add and remove an electron. So it just give us a 1. Equals 0 if I even, 1 I is odd. Is odd, yeah, very odd. And of course we also have the term, the I plus 1 term, which will be exactly the same. So it will just give us the 2 before that. So int equal to 2u sum over Ci. And because it's the same term here, I accidentally wrote it's the same term. We have h equals I plus I'm going to explain it in a second. Yeah. Notice that only our even Hartree term remain. So to keep only the even terms, I put a plus 1 plus minus 1 power of I, which is equal to 2 if I is even. So it only adds to the even terms. Yes?
Can you repeat why the even is remain?
Here?
Yes.
The odd remains.
The odd.
Like
Because of the ground state.
no, it's this is right. It's even. This here even cancels out because we only have odd terms. So notice that the mean value will be even, but the operator attached to it, because remember here we need to have Ci plus 1 Ci plus 1. These terms will be odd. This term will be even, and this will be odd all the time. So we only add the 2u when these terms right here are even. Okay? They ask us to write the correction to epsilon, technically to epsilon 0, but you can just open epsilon I and find the correction to epsilon 0. It's the same.
You are going to upload these notes.
I'm going to ask Frat to let me upload it. There's a bit more writing in the text itself. I just because we only have 2 hours to do 3 questions and try to do it as fast as I can. So I'm sorry if sometimes I miss a little bit here and there. I'm going to try. I need to ask Frat. All right. In part B, this question, part B, we're given we say they're telling us that they have a new ground state, G, for supposedly the corrected ground state, and they give us the expectation value for Ci dagger I to be equal to 1/2 plus delta minus 1 to the power of I, and the expectation value for C2j plus 1 dagger C2j should be equal to 1/2 sine rho plus 1 to the power of j. They also give us that rho, equals to plus minus 1. It's either plus 1 or minus 1. Oh, they don't tell us which. And they want us to end up mean field approximation h of nf equal to sum over j sine j. H, J, and F psi J. Well, we have psi J dagger equals to C2J, C2J plus 1. All right. Yes.
I have a question. Why did you choose these questions on basic now?
Because I saw them and I thought they were good, and then I solved them. This is completely arbitrary. It's just the first good question I saw. This specific is a good one because above here we wrote it in the terms of I, where I flips between even and odd, but they're clearly trying to aim for us to move to even and odd representation. So in even and odd representation, the first expectation value that they give us, when it's even, equal to 1/2 plus delta. When it's odd, we're equal to 1/2 minus delta. Okay. And now we have here. Let's first correct this Hamiltonian so it will be separated to even and odds. So, 0 sum so I equal to sum over 2j C2j j plus epsilon 2j plus 1 C2j plus 1 1. Right? Then in order to take the interaction term and separate it to odd and even, I'm going to take this base term, write all the four different elements, all the 4 different parts of the Hartree-Fock approximation explicitly, and then I'll transform each part into an even and odd representation. So, equals G over I. So, the Hartree term in green, first of all, we have Ci dagger Ci plus 1, Ci plus I plus 1 dagger plus Ci plus 1, Ci plus 1, Ci plus 1 dagger, Ci dagger, Ci. And the Fock term, the minus, will be, first of all, it's right, Ci dagger Ci plus 1, Ci plus 1 dagger Ci minus Ci plus 1 dagger Ci dagger Ci plus 1. Right? The Hartree-Fock has 4 terms, even though we only talk about 2. We usually combine those 2 by changing indexes and combining the Hartree terms by changing indexes. Here I just wrote them explicitly to be most simpler. Notice that when I is even, the first term will be even and the second odd, and when I is odd, the first term will be odd and the second term will be even. So we always have the two flipping terms. So I can just take I to be equal to j, move it to I to be equal to j, and then we have here a sum. Instead of a sum going from I to even to odd, we'll have a sum of even, sum of odd, and the same I can do in the Fock terms, the exchange terms. So I'm just gonna replace I with j, and this will keep the same amount of terms, just from the fact that those 2 are exactly the same, just switch each time. Okay. G equals C to J, dagger C to J, C to J plus 1, dagger C to J plus 1, plus C to J plus 1, dagger C to J plus 1, C to J, dagger C to J, minus C to J plus 1, dagger C to J plus 1, dagger C to J, minus C to J plus 1, dagger J. Alright, so I transformed all of our parts, all of our different operators to be in the convention, the as convention, with even and odds. Now we just need to organize everything, because it's all a bit of a chaos right now.
איך אתה יודע שהאינדקס I, הרי האינדקס I פה מתחיל מ-0, אם אתה נגיד מוזיז את כל האינדקסים אחורה באיברים מסוימים.
I'm not changing. I'm seeing, but I saw that when this is even, this one's odd, and vice versa.
Okay.
So instead of counting even, odd, and the same here, I'm going to count even, and the same thing odd. Then I basically like did a card shuffle of the terms. So I'll have one time I'll have the even, one time I'll have the odd. And the same exact argument can be made with the Fock term. Just a bit more complicated because it will be even then odd then even. So maximum do a little bit of a
shouldn't there be like 2 times this, because like if you do like sum over j and you replace I with 2j, and then you do sum over j, replace I with 2j plus 1, so you get like twice, because like you didn't count all I here.
See? Yeah. Yeah. I didn't write it in my notebook, but I think you're correct. No. Yeah, it should be 2. Let me just, for example, let's look at the index I equals 1 and I equals 2 just to understand this. When I equals 1, this term right here would be C dagger 2, C2. And when I equals 2, this will give us C2 dagger C2. So we sum twice over this even term. So there's a 2 here. Thank you. I will correct it in my notebook. Now, to organize this equation, we just need to find all the prefix, all the operators. These 4 terms, these 2. We already know that epsilon to j equals to epsilon 0 plus v. Epsilon to j plus 1 equals epsilon 0 minus v. And now, C to j dagger C to j be equal to, what did you say? Equal to 1 over half plus delta. C to j plus 1, C to j plus 1 equals to 1 over 2 minus delta. And C to j dagger plus 1, C to j equals to 1 over 2 1 plus delta plus 1 over j, and C to j dagger C to j plus 1. This will just be the conjugated first term. So it will be 1 over 2 conjugated 1 plus 1. Remember that this row is just plus or minus 1. It's real number. So we just get the dagger here. Okay. Overall H, we have the sum over J on everything. We have this epsilon 0 plus V comes before the term of the form C2J, C2J, and we have it also here. Right, so we need to add this term. And this term, the C2J plus 1 to C2J plus 1 is half minus delta, so plus half minus delta times u, times 2u, right? Correction. 2u, that would be C2j dagger j plus. Now for the odd term, or diagonal term, epsilon 0 minus v plus 2 1 over half plus delta u. C2j plus 1, C2j plus 1, dagger. And now the cross terms, here with a minus. Is it a G or U? Like, no mistake.
Should be U, yeah.
There's a U here, not a G.
Oh.
The G stuck with me from the last question. also write it here? No, it was so minus. Now the first term C2j plus 1 C2j have this for it minus u 1 plus O minus 1 of j C 2j plus 1 dagger C2j minus u psi 1 plus rho minus 1 of j C2j dagger C2j plus 1. Now those 1, 2, 3, 4 terms will be the terms of our matrix given here. So H equals to dagger j. Then we see the first term is the even, the second term is the odd. So even, epsilon 0 plus 2 v plus v plus 2 1/2 minus delta u. And now even odd, so with the term here, minus u sine 1 plus 1 minus 1 of j minus u sine conjugate 1 plus rho minus 1 to the power of j, and the term odd is epsilon minus v plus 2 1/2 plus delta u. Sorry, side j.
You changed the G to the U, yeah?
Yeah. So now they want us to find the eigen energy, eigenvalues of this matrix. This is the next thing that they asked. Since this is a pretty big and pretty ugly matrix, I think you all agree, I'm going to write the first term A, B, delta, dagger. So just going to be equal to sum of the j, side j conjugate A delta minus delta conjugate B sine. Just for simplicity.
להיות עם 2J וה-2J ועוד 1.
Here's the definition in the question. All right.
You forgot the note on the epsilon. Epsilon not on
So to find the values, the eigenvalues, we will take determining A minus E minus delta conjugate minus delta B minus E. Okay. So be equal to, I'm just gonna multiply these two together, multiply these two together, and I'm just gonna open it straight.
But gave us this as a formula.
Huh?
She gave us a formula for the eigenvalues of a 2x2 matrix.
They gave you like, you have A, B, C, D in the formula. And you get everything in a silver spoon, you know. Yeah, damn. Back in my age, I mean, I'm not that older than you. Back in my age, there was no formulas.
Oh.
We needed to prove everything from zero in that test. So what am I to do or not? I'm going to do it anyway. Okay, minus E plus B plus E squared plus I think there should be a minus here. I'm mistaken in my notes. Next time this minus, yeah, it should be a minus and my notes are wrong. Ooh. Okay, so this is just a square equation. E plus minus equals A plus B plus minus square root of A plus B squared minus 4AB plus 4 squared divided by 2.
How much time will take the exam?
The exam will have 4 hours. Honestly,
Without the time?
4 hours. Honestly, I think if you know the material, you should finish this like 2 hours or under.
2 hours.
I mean, that's my opinion. Might be wrong.
Yes.
No, I'm not. I'm never wrong.
Question 1 is it can be long. I mean, it can be it's
Very
easy,
long.
but it can be lengthy.
Yeah, but if you know, like every question, all right, I'm hoping that the main takeaway that you get from this question, it's not the physical answer, just the step that I do. Like the transformation, the moving everything into one convention, taking a matrix, etc., etc. The steps are more important than the actual equation. All right, so I don't want to solve this with an A and B in it. It doesn't look nice. So I'm just gonna calculate each of these terms. So A plus B. Let's solve with A plus B. A plus B equal to this term plus this term. So we see first of all that the delta cancel out, the lambda cancel out, and the V, sorry, also cancel out because here it's a minus, here it's a plus. So we're left with epsilon 0 plus U.
Two.
2 times.
And you also have 2. Plus
What's
2.
this?
No, plus 2.
It's to
Plus-
V, not to you.
No?
No, V here plus minus, so it's 0.
Yeah.
The lambda cancel out,
Ah, with you.
so it's epsilon 0 plus U plus epsilon 0 plus U. So it's 2, epsilon 0 plus 3.
It's you. So on the side with you.
Oh. Okay.
Sorry,
Yeah.
what do you mean when you wrote that you represent A like
This entire term,
it's A?
A,
The shift line.
Oh shit, it's
E. Right? Okay. This is a simple term. Now, A times B. Alright. So we get length here. Plus V minus delta U. So 0 plus V plus 1 over half plus In my notebook, there's the full opening of these two terms, but there's two.
You can like do a minus b, like squared instead of this term.
Yeah, there's many ways to simplify it. In my notebook, I wrote it explicitly, entire calculation. I hope they should let me upload it. If not, you can open it yourself if you would like to. But generally, we see that the v, for example, v epsilon 0 and minus v epsilon 0 will cancel out such and such terms. Overall, we get 0 squared plus 2 0 u minus v squared plus 4 over 4 minus lambda squared u squared.
It's half plus lambda.
Lambda.
Delta?
That's a lambda.
Oh, 8.
That's a delta? Damn, I'm so bad at my Greek letters. Where?
Lamed.
This one? What about it? What about
Yes, what is it? It's 8? What?
it? This is just a number.
That is plus delta.
Ah, delta.
Oh, this one. I don't know. Wait.
Lamed.
Yeah, probably. Alright. So now we're only left with delta squared. So now that our delta, whatever we have, so it's u squared, also the value of y squared. And then the terms inside, this term will just be 1 plus 2 minus 1 of j. And then, since this term is either plus 1 or minus 1, this entire term, and this term is exactly the same sign, just plus 1, will be equal to 2 u squared value squared 1 plus O. Putting everything back into this equation. Equals, so a plus b, first of all, so it's 2, 0 plus 2u, plus minus square root of 4 0 squared plus 4 0u plus 4 squared. This is going to be a long one. Long minus minus 4 epsilon 0 plus 8 epsilon 0 v plus 4 v squared minus 16, I guess. Over 4 minus squared u squared. Plus, it should be, it's a plus. Plus this term, 2 times 8 plus 4 plus 8 u squared 1 plus g.
What do you want? 8? 8?
There's an 8 here, sorry.
It's 8 too?
8 epsilon 0 v. This 16.
No, the
8 u squared.
Okay.
Right. Just take a different marker. A lot of the terms here cancel out. This term, so this term, this term, this term.
אז 8 epsilon 0 v, עוד פעם לעבור על
There should be. No, but this one doesn't cancel out. Still plus here. No, it's minus. Oh, it's doesn't cancel out. Yeah. Bye bye. Just need to walk organized and everything will be fine.
מה האיבר השלישי שם בשורש? זה 4U או 4V בריבוע שיער?
This one?
כן, מה זה?
This one will be A plus B. It's supposed to be a V, I'm pretty sure.
כי אמרנו שזה לא מתקזז.
Oh, it's a U.
U וזה מתקזז עם זה.
Cancel out. Cancels out with this term right here.
אוקיי.
This term.
פשטה מנהדה.
You sure?
ואיך האיבר השני אתה שמים שם 8 E0V? האיבר השני משמאל? השני משמאל. לא, יש 8 E0U. למה שהוא מצטמצם?
נכתוב את האיבר הבא ונראה מה קורה.
I forget the town. This is a U here, not a V.
אז למה הוא מתקזז עם האיבר הערבי?
Well,
This is a U. And this term, this term is also a U. Sorry, whenever there's a U and a V, my writing is bad. No V in the term. Okay, 1 second. There is. It's supposed to be. Because I'm going to remove a 2, so okay, 0 plus U minus. So it's minus square root of.
now it's good.
Yeah, now it's correct. 2 squared plus 16 squared. What's 16? 4 squared U squared plus 2 U squared. These are the energies. I'm giving you a moment.
I think there is like should be another term
Which
because
term?
like I did like instead of this I did like a minus this squared because you can see in the square root.
Yeah.
And then if you do a minus b, you get
2v
minus
minus 4 lambda.
4 delta u,
U
and
squared.
then in the end it will be like v squared plus 4 delta squared u squared plus not minus 4v delta u.
Minus 4v
Delta u.
delta u.
But is it really important right now?
Yes, we can move
Yeah,
ahead.
Yes, it's
Please move on.
Not important. No, because it's not the point.
Yeah.
Yeah, it's not the point.
But you can discuss it.
But if she will get this question,
Okay, but you will not
So if-
remember by heart
זה לא
every
משנה עכשיו.
term.
Yeah, I might have done it like too quickly. And,
It's okay.
אנחנו צריכים
התוצאה זה לא
לחזור,
כזה
יאללה.
משנה.
But anyway, this is we're not touching the energies again in this question. All right, now they're giving us that G equals, say J, gamma, J minus dagger 0, where gamma J minus dagger equal to cosine theta divided by 2, C2J dagger plus sine theta divided by 2, C2J is 1. Right? This will just be similar to the Bogoliogov transformation, so following the exact same step as there is in the tutorial book, except that we have dagger instead of dagger instead of creation and relation, we have to creation. So following the exact same step in the tutorial, we know that J minus, let's just write J plus be equal to cosine theta divided by 2 C2J plus 1 minus sine theta divided by 2 C2J. And again, following the exact same same transformation where gamma plus gamma minus equals UV. U C J plus 1. Doing the exact reverse transformation as we did in the Bogoliogov transformation, we get that C2J plus 1 equal to cosine theta divided by 2 J plus sine theta divided by 2 gamma J minus C2J equal to minus sine theta divided by 2 Right, 1 second. What? This entire transformation here is just Bogoliogov.
No, it's delta.
Where delta?
J.
J?
Yeah.
It's just a J.
And
Plus.
לפני זה.
גמא J. גמא J מינוס. בסוף.
Not 2.
It's index.
Adding question, they have only given the expression for gamma dagger J minus.
Yeah, but
So we need to find ourselves what is gamma J plus.
notice that for the transformation to be unitary, it has to follow this kind of form,
Okay.
like we saw in the BCS. I'm skipping on the arguments here because the argument will be just copying from the BCS notebook.
Just how you get gamma minus, except of the gamma.
Gamma minus?
Yeah.
I'm just taking the conjugate of this, which is just removing the conjugates here.
Which notebook?
The tutorial notebook, Yudkin tutorial
No,
notebook.
I see it, but it's
What? 8?
because of the plus, it's confused.
Yeah, U will be cosinus to G to theta divided by 2, and V will be the sinus. It's fine. Pretty sure it's fine.
So you were saying something, the matrix to be unitary, we need to find gamma J plus such that.
No. For the matrix to be unitary, we need the determinant to be 1.
Yes.
Yes. And since we already know that these two terms are, we can sort of assume that we're looking for cosine squared plus sine squared. So, and also in the question they gave a hint that it's just like the BCS. They say in the question. Yes.
לא רוצה אבל גמא J פלוס פלוס וגמא J פלוס כדי שזה יהיה כמו בוגוליוב, כמו שזה פה למטה, נכון?
Notice that it's exactly like the Bogoliogov, but our terms are weak. You don't have like a BCS term when we need to take a dagger, a creation and annihilation. So it's a dagger.
אוקיי. זה נגיד גמא J מינוס וגמא J מינוס דגר שם, כאילו שזה יהיה הכי...
No.
למה לא?
Because this is how you open the Bogoliogov tutorial. We need to do two different terms. Just again, in the Bogoliogov term, we had the mixing between the creation and annihilation, so we need to have a creation operator in one of them. But here we don't have the mixing, so we can define fully on annihilation term, which is much simpler in my opinion. Okay. So they gave us a transformation. We played with it a little bit to find the expression for gamma by C and C by gamma, both directions. And they want us to find the terms, here and psi. The question?
כן, אתה יכול לחזור איך הגעת לגמא, מגמא דגר לגמא?
מגמא, כאילו, מפה לפה?
כן, כשאתה עושה לי דגר ל-C2J דגר, אתה מקבל C2J ולא...
I got this term because I know by using the cosine and sine that I'm expecting a Bogoliogov transformation. So this term I didn't calculate directly. I just know it looks like that. If you want to see it more expanded, again, the tutorial notebook on the BCS, it's exactly the same thing except that we have the same kind of operator instead of a dagger and a non-dagger. Like instead of creation and annihilation, we have two creation. Okay. But those creation and annihilation, that's the vector outside, don't matter in the matrix. So the entire transformation, which is based on the matrix itself, not the operators, will stay the same. So it will be exactly the same transformation, just with different name to the operators.
Okay.
And this, to calculate it explicitly, it will be very long. So you shouldn't do it in a test. You should, if you see something that has a squared plus squared equals 1, you should know immediately that it's a Bogoliogov or similar to Bogoliogov. So all this equation are just directly from the notebook. That's it. Okay, so to calculate those delta and phi, what we can do is look at part B, where we are given. Let's start with the delta, for example. We are given Ci dagger Ci equals 1 over 2 plus delta minus 1 J. Okay. Let's just for simplicity, let's for example take, let's see what I took. I took the, what is it? I took the even terms. So the even terms. If you want to calculate this explicitly, we need to make sure that our state and our operators will be in the same basis. Right? Our state was given in gamma basis, but our operators are in the C basis. So we either need to change the state from gamma to C, or the operators from C to gamma. Since this will give us a very long and very annoying multiplication, I'd rather change the C here to gamma, which is why I found the reverse transformation first. All right. So I'm going to take the even term, so it's C2G, C2G. We have it right here. So G of minus sine divided by 2 gamma J dagger plus cosine divided by 2 gamma J minus dagger minus sine divided by 2 gamma J plus cosine theta divided by 2 gamma J minus.
What you're doing now?
I'm finding delta by calculating explicitly the calculation that they gave us before. Okay.
What is theta?
Delta?
Theta.
Theta? It's an angle. It's an angle of the Bogoliubov transformation. You remember in the very end of the BCS, we found it by finding the vectors, the eigenvector and eigenvalues. Here they didn't ask that. They want us to find delta as a function of theta. So we don't need to find them in this question. All right? So we see here that a ground state is only composed by a minus gamma, only for minus particles, the quasi-particles. So gamma J plus dagger operating on the left will operate on 0, so this one disappear. And gamma J plus operating on the right will also operate on 0, try to annihilate the 0. This will also disappear. Right? And since we have one quasi-particle in every since we have one quasi-particle in every minus state, this multiplication, this gamma dagger gamma, just be a 1. So everything here, overall, is just equal cos theta divided by 2 squared, or equal to 1/2. Since we took even, this will be a plus delta cos 2 squared. So delta just equal to cos squared of theta divided by 2 minus 1/2. Right? And now, fine. You can still catch it while it's moving. Come on.
Why did we have to take it off further?
Right here, because it's C, dagger C.
See,
So first of all, I'm taking the dagger of this term, then the normal. This one, and this one, both cancelled out because our ground state only has minus quasi-particle, not plus. Okay. Well, where was I? Oh, right. Fine. I already lost. So phi, we can find exactly the same just using the second given equation. Second given equation is C 2j plus 1 dagger C 2j equals 1/2 sine 1 plus O plus 1. Right? Now, to calculate this term explicitly, C j plus 1 dagger here, so it's cosine divided by 2 gamma plus dagger sine divided by 2 gamma j minus dagger, and then sine theta divided by 2 gamma j minus plus cosine gamma j plus theta divided by 2 gamma j plus. Right? For exactly the same reason as before, this is equal to minus did I move the correct one? Oh, this one is supposed to be the plus, this one is supposed to be the minus. Oops. Want to be question if I would make a mistake. So it's sine theta divided by 2 cosine theta divided by 2 equals to 1/2 v 1 plus 1 j. Notice, before we continue, notice that this answer will only be correct when j is when rho times j minus 1 to the power of j is equal to 1. Whenever it's equal to minus 1, it will just be equal to 0, and we wouldn't be able to divide here. So the answer given is only when this is 1. So the 2, I can take the 2 to the other side, and then 2 sinus theta divided by 2 cosine theta divided by 2 is just equal sine theta. Equals to 9, 1 plus 1 minus 1 j. Equals sinus theta 1 plus 4 j. Here we go, question 2. Yes.
מה נכון בזה? כאילו אתה אומר שאתה לא יכול פשוט לחלק ל-0, זה מה נכון לחלק ספציפי.
Yeah. We also need to remember that when we write the theta here, it's actually theta of j. We have no condition that all the thetas are the same. We just an index that I didn't give in the question, so I didn't use it, but remember that it can be a different theta for each mode. So again, what the heck? Yes. No, it's not recorded. Right. It's recorded. But remember, I said this is only correct when this one is not 0, so it will be 2. So it's even simpler. 1/2. Oops, no cos sine. Okay, what's the time? Okay. Well, we'll exceed the time a little bit, so but we still have to do a Granger question.
They also asking the question to find like
What?
delta and v by v and u, like to find theta expressed by v and u and then relate them.
I completely skipped over the last line. Right. Well, okay, so since I didn't write it, let me just give you the way to do it.
Wait, about the 0, what did you say about it?
0? What 0?
Dividing
Here?
by,
If j, let's say this row right now is 1. So if j is odd, the entire thing is 0. So you can't really divide by 0. Phi is not to infinity. So we know that this answer is only correct when this term equal to 1. So I can just replace it with 1 divided by 2. So the last question, right? I didn't do it, but I'll leave it for you. The way you find theta by the terms of v and u is by finding this matrix that's supposed to diagonalize your system. So if you like the BCS, it will be just bring this up.
So the same as the BCS,
Yeah, like in the BCS,
same, just we got the
you got u equals to square root of 1/2, 1 plus v divided by k, and v equals to 1/2 1 minus b.
E and U?
V nu, so one is the
Where the
cosinus.
No. Oh.
This is just come by finding the explicit form of this matrix. By finishing the diagonalization of a 2x2 matrix, which I'm sure you know. Alright. We don't have time. Let's do question 1, 2001, 2021. Question 1, 2021A.
כבר יש את השתי שורות שלו.
יירגע.
מה?
יירגע.
תשאיר את השורה האחרונה שם בבקשה.
זאתי?
כן, כתב.
כל עכשיו שאני אגיע אליה זה כבר תסיים. יכול למחוק אותה? חצי?
All question must, yeah.
You have to do all questions. Rarely, there's a bonus.
Ah, we have bonus?
No, he said rarely.
Rarely. I cannot say if you have or don't have a bonus. This is above my pay grade. Q1, 22A. Not so funny.
I have a question. How much points are homeworks for the exam, you know? Plus...
If I remember correctly, homeworks are like 20%. Thank you. I just give the grade. I had to further with it.
No, but when we get the exam...
The exam is 80%, so...
No, but plus how much... which
20%.
number?
20 plus 8.
Take the exam, multiply it by 0.8. Take the homework, multiply it by 0.2. Unless there was a different question, but the question about the grading come later. I don't have time.
Okay.
All right. Question 1, always about Euler-Lagrange equations, because you'll never get rid of Euler-Lagrange. It will haunt you forever. Because I'm not joking. It will come back later. You least expect it.
So it's which section?
It's
A?
2020 A.
Ah, okay.
Q1. What?
2020 או 22? אתה רשמת 22.
What is the year?
Oh!
2022.
21.
20.
Sorry. Sorry.
It's important.
It's been a long day. Tired. Just don't write the Lagrangian. I'll talk for a second. Now it's your time to talk.
This one is available on Drive.
Yeah, I'll reserve it.
21.
תראו, יש לי פרשת בביטון. את יודעת שיש פתרון לזה? כן, יש פתרון בדברים.
גרוע.
מה הבעיה שלכם עם הפתרון שלי, אה?
פתרון של
כמו שלך יתר במבחן.
יש חומר פתוח, אני כאילו...
יש חומר פתוח, וגם, and I expect you to write everything, so it will be in the test. You will have it in the test.
What would be in the
It's big
test?
low.
They ask if my solution will be in the the materials for the test, and the material that you bring. So you can bring it if you write. You can bring it. I don't know.
I don't like
It's with printed material, yeah?
I mean, if you bring something that you hand wrote, I think she'll accept it. It'll be good.
So,
Can we have a question about the test after
כן,
the
בבקשה.
tutorial?
So,
So it's a little bit of a waste of time. It's given that phi belongs to real. It's a real function, and P is a complex function. Hope all of you remember your science from mathematics. And let's see if they give anything else is important. K1, K2, J lambda, K0, and you don't even need to use this. I will just give you already that they give. So, as the same in every other Lagrange, well, actually this one's not different. They want us to take the Euler-Lagrange equation, decay from this the Euler-Lagrange equation, and put in a solution 0. I. Alright. Well, 0 is bigger than 0, and no. And I want us to find an expression for find u and okay. That's what they asked for. Okay, so it will be very tempting to put what? This is what they asked. When we do our Lagrange equation, we never put the solution the Lagrangian, being normal. First of all, we create the Euler Lagrange equation, then we put the given solution. So, the Euler Lagrange equation. Let's start with the phi. Sorry. And the first term, the direct derivative, we see that it exists only these two terms. Yep, only these two terms. One of them will be minus 2 m squared, plus lambda absolute value psi squared. Right? Now, the t of now the time. Okay. Time conditions, we only see it here. K1 time, sorry, d squared. No one. And then there is the special derivative. This writing is a bit, it's wrong. I'm just going to say it in a second. I'm just going to explicitly say it. Because this derivative this derivative in the denominator is not, it's not legal to write it like this, technically. Huh? Yeah, but what I'm trying to say is that I'm taking all, like, this equals to sum of I, to I, right? This is